All right, let's just dive right in. I want you to forget everything you thought you knew about our quiet, expanding universe, because today we are popping the hood on a totally radical new theory, one that recasts the cosmos not as some empty void, but as a colossal, perfectly tuned engine. Yeah, we're going to do a full mechanical teardown of the oscillating Brane theory. So, for decades we've had the standard model of cosmology, this familiar idea of the universe as, well, an inflating balloon. But here's the thing. Recent data, especially from telescopes like James Webb, is poking some pretty serious holes in that balloon. What we're observing out there, it's just not matching the old model. This has kicked off a bit of a crisis, and a whole new reality is starting to emerge. The idea that our universe is actually a dynamic four-dimensional membrane vibrating in a higher dimensional space. And get this, it's all awakened by the strong nuclear force.
So if the universe really is this living, breathing engine, you have to ask, what's powering it? Well, this new theory proposes a kind of cosmic motor that runs on a principle you probably experience every single day, maybe without even realizing it. It's called stick-slip motion. And this simple idea, this could be the very engine that drives all of reality.
And it's kind of wild how universal this whole stick-slip idea really is. I mean, think about a violin bow catching on a string, right? It sticks, it builds up that tension, and then it slips to create a note. Or, on a much bigger scale, tectonic plates locking up for centuries, building up just immense pressure before they finally slip and, bam, cause an earthquake. So what this theory suggests is that our entire universe does the exact same thing, just, on a 2 billion year cycle. It stores up this incredible geometric tension and then all at once releases it.
Okay, so any great engine, right? It needs key components to work. And this V8.0 cosmic motor, it's no different. We're about to break down its four main modules. You've got the muscle. That's what provides the raw power. The metronome, which keeps the timing absolutely perfect. Then there's the cloak, which, well, it hides the whole operation in plain sight. And finally, the damper, which is crucial because it stops the whole thing from just tearing itself apart. So let's start with the power source. Where does all this energy come from?
All right, first stop on our mechanical teardown, the muscle. This is the component that has to answer maybe the most fundamental question of all. What kind of force is powerful enough to actually bend and stretch the entire fabric of space-time?
And look, this is a huge problem. We're talking about moving a structure that is 93 billion light-years across. What could possibly act as the piston for an engine on that kind of cosmic scale? Well, the answer, it turns out, might be hiding in the very architecture of the cosmos itself. Okay, so here's the truly mind-bending part. The cosmic web? That vast, beautiful network of galaxy superclusters? It turns out it isn't just passive scenery. The theory says it is the muscle. The immense combined gravitational weight of literally billions of galaxies presses our four-dimensional membrane down into the fifth dimension, relentlessly stretching it. And this constant pulling, that's the stick phase, is just building up this tremendous potential energy over that 2 billion year period. Okay, so we've got our power source. Check. But just having a brute force muscle isn't enough, right? Any engine worth its salt needs precise timing, especially when you're talking about cosmic distances. And that brings us to Module 2, the metronome.
And this, right here, this is what's called the synchronization paradox. Think about it. If one side of the universe snapped back into place, the speed of light, our ultimate speed limit, says it would take 93 billion years for that signal to even reach the other side. So reality wouldn't oscillate and sync, it would just shred itself into a mess of chaotic ripples. The engine absolutely needs a way to bypass the normal laws of space.
Well, the solution is as elegant as it is, frankly, bizarre. A universe-spanning network of ancient microscopic primordial black holes. We're talking about tiny little anchors, smaller than a single bacterium, that are theorized to be connected to each other through wormholes in the fifth dimension. What this does is it creates a kind of quantum shortcut, linking them all together into one single interconnected system.
So here's how this quantum metronome actually works. As the cosmic web stretches the membrane, that tension just builds and builds, until it hits a very specific, very precise physical limit. It's like a cosmic breaking point, at 257 mega-electron volts. The instant it hits that threshold, the entire quantum network of black holes acts like a single, universal pressure valve. It releases all that tension, everywhere, all at once, instantaneously. That is the slip. Okay, now if you're a skeptic, and you should be, there's probably a very specific question forming in your mind right about now. And that question brings us directly to Module 3, the cloak.
And the question is this: if there are literally billions of these tiny black holes pinning our universe together, why haven't we ever seen one? I mean, astronomers have been hunting for these things for decades using a technique called microlensing. And you know what they've found? Absolutely nothing. The official mainstream conclusion is, well, they just don't exist.
But this theory argues that we've been looking with the wrong kind of eyes, so to speak. It all comes down to a really fundamental difference in optics. So imagine a big boulder in a river. It clearly disturbs the water flowing around it, right? That's kind of like geometric optics, how light bends around huge, massive objects. But now what about a tiny little pebble in that same river? The long river waves just wash right over it, completely undisturbed. That's wave optics.
And here's the big reveal. The primordial black holes we're searching for have an event horizon, their Schwarzschild radius, of about 3 nanometers. Okay? 3 nanometers. But the wavelength of visible light we're using to try and find them is about 600 nanometers. Our detection wave is 200 times larger than the target. The light from our most powerful telescopes is literally just washing over these quantum anchors as if they weren't even there. They're basically cloaked by the very physics of light itself.
Okay, so our cosmic engine has power, it has timing, and it even has a clever way to hide. But any engineer listening right now is probably spotting one more potentially fatal flaw. This machine needs an exhaust system. And that brings us to our final component, Module 4, the damper. The problem is something called runaway energy. See, in a closed system, each one of those violent slips would just add more kinetic energy into the next cycle. The oscillations would get bigger and bigger and bigger until the vibrations became so extreme that they would literally shatter the fabric of reality. It's called resonant failure. And early computer models of this idea actually showed this happening. But here's the beautiful part. It turns out our universe is not a closed system. The fifth dimension itself acts as the ultimate cosmic shock absorber. When that membrane snaps back, the sudden acceleration has to go somewhere. So it radiates that excess energy away, bleeding it off into this higher dimension in the form of what theorists call bulk gravitons. This acts like a permanent brake, perfectly stabilizing reality and making sure the engine never, ever redlines.
So, there we go. We have all the parts on the table. Let's put them back together now and watch this incredible machine in action, operating in perfect, beautiful harmony.
And this just shows the full cycle perfectly. It's really like a cosmic symphony. You've got phase 1, the stick, the cosmic web muscle stretches the membrane, building tension. Phase 2, the threshold, that tension hits its absolute physical limit. Phase 3, the slip, the quantum metronome triggers an instantaneous, universe-wide release of all that energy. And finally, phase 4, the exhaust. The damper bleeds all that excess energy safely into the fifth dimension. It's a perfect, elegant, self-stabilizing cycle.
But what about proof? I mean, what does the exhaust of a cosmic engine even sound like? Well, that incredibly violent slip phase should generate massive ripples in spacetime, gravitational waves. And wouldn't you know it, just recently, observatories detected a persistent nanohertz hum of gravitational waves coming at us from all directions. So could this be it? Could this be the actual sound of the universe's engine, running like a finely tuned machine? It really makes you wonder, what other cosmic mysteries, what other phantom particles we're hunting for might just be the gears turning in this grand hidden machine?